Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we will be continuing to solve the UPSC CS Mains 2020 paper that we were solving since the last quite a lot of videos. I guess I don't remember the exact number. Okay, but many videos are there in this series. Okay, so as I've already told you about the the structure and the pattern of this paper, that is, it is a competitive, it is not an objective type question. That is, it has subjective questions in it. No MCQs, no fill in the blanks, nothing is there. Okay, this has advantages and disadvantages. The advantages being you don't have any negative marking over here. If you get a question wrong, you will be straight away given 0, and no negative marking will be taken as such. Okay, but the disadvantage over here is that you have to write each and every step of the question that is provided to you correctly, so as to get full marks out of the that particular question. Okay, any step missing in between, any step wrong in between, any step you have written extra, and that became, if that is wrong, you will be some marks will be deducted for that mistake. Okay, so these are the advantages and disadvantages. I already discussed this like in almost every video, I guess. Okay, so let us not look into that now very deeply, because we need to finish the questions obviously. So in the last video we did up till question number 6E. So I guess 4 or 5 videos more would be required, and then we will be finishing the set. Okay, so in this video we'll be starting from question number 7A. Okay, so this question, so for 7A has two parts, so we will be dividing the question accordingly and then solving. So the first part is 7A1. So the first part of the question says that a reaction complex is twice the time of its half-life period. What is the order of the reaction give reasons? Okay, so it says that the reaction complex is in twice the time of the half-life period is. So as the question says, the twice the time of its half life in two half lifetimes, the reaction is completed. Okay, the reaction is completed. This actually, the question that is given here is a trick question, or you may say either it is a trick question or there is a printing mistake in the question. Okay, so let us consider it as a trick question, that the question is correct. We have to it is given to give explain the reasons. So we will be explaining why this is a trick question and why the given statement is wrong. Now, as I told, the given statement is wrong because it says that the reaction completes in twice the time of half-life period. So, let us take for example, like if the initial concentration is A, then after one half lifetime, after T half, one half lifetime, the reaction will be reduced to half of its amount, that is A by 2. And now this A by 2 in another half lifetime, T half, would be reduced to the half of A by 2, which is equal to A by 4. That is 25% of the reaction, 25% of the initial concentration. Okay, be it any kind of reaction, this is the exact mechanism that follows. That is why we denote it as T half, right? T half means the half lifetime, that is the time required to complete half of the reaction. So for half disintegration, so first half disintegration is taken gives A by 2, and the second is a half disintegration gives A by 4. So obviously, if two T half lives are passed, then the reaction won't be completed. Instead, 25% of the initial concentration would be left still. Okay, so that means there is no point of discussing what will be the order of the reaction, because obviously we know that because some of the reactant is already remaining, the process is hence not completed totally. And as the statement says that it is completed, this question is wrong. The statement is wrong, and the question might be a trick question. Okay, the other formula that we need to know, because many a times this kind of sums come, and if we consider it as a like printing mistake, then the formula that might have been used for the calculation of the sum, that is t half 1 divided by t half 2. Okay, is equal to a2 divided by a1 to the power n minus 1, where n is the order of the reaction. Okay, So n is here the order of the reaction, and the T half 1 is the half life at some concentration A1, and T half 2 is half life at some concentration A2. So if two concentrations are given, and for those two concentrations we have corresponding T half, then we can put the value over here and calculate the value of n from the order of the from the this equation giving us the order of the reaction. But this as already told, this statement makes no sense at all. So let us leave that without wasting our time. Okay. So this was the reason that was asked in the question. So you have to explain it properly with proper sentences why this statement is wrong. As I have told you, please take notes of that. You may just rewind the video and see. So please take notes of that and just write it down properly about why this statement is correct. 2 T half doesn't mean the reaction is completed. Like, this is a very layman type of thing, that if we complete 50% in one time, then another 50% will be completed in another time. But that is not the case at all. The 50% left, this 50% will be considered as 100% amount, and then it will be again undergoing T half, that is half of this 50% would be disintegrated. So we will be left to 25% only. Okay. This is the logic behind the T half concept. Okay. So let us not waste our time anymore in this question. We have already wasted quite a lot of time in this. So let us move on to the next question directly. Okay. Not the next question actually. The question, the same 7a, the second part of this question, that is 7a 2. Okay. This is a kind of an interesting question. It says that the reaction completes in. I'm sorry, I just read again the above question. So the next question says that show that for a first order reaction. So reaction is first order reaction. N is equal to 1. Okay, so first order reaction, the time required for 99.9% completion is almost 10 times more than 50% completion. Okay, so 50% completion. So let us say for 50% completion, that is the T half. Okay, so let us derive firstly the T half value, how it is derived, and then we will be moving on to the other part. Okay, so the integrated rate law for the first order reaction is given as Kt is equal to ln A by A minus x, where K is the rate constant. Okay, K is the rate constant, decay constant, or whatever you may call it. Okay, T is the time taken, A is the initial concentration, and A minus x is the concentration left after time t, amount left after time t, left after time t, time t. So let us put the first condition in the first. So case 1, we have case 1, uh, k is not known to us, so we will keep it like that. T half, so we have to show that the time required, so we have to calculate the t only. Okay, so we will be keeping the t here. T, the first case considers about 50%, so we will be considering at this t as t50. This one is equal to, basically this t half, but for this question we will be considering it as t50. So 1 by k into ln of a by, let us consider the total amount to be 100, just assuming. So the final amount would be 100 minus 50. Here x is the amount consumed, and the percent that is being like required is 50. Like 50% of the amount is consumed, 50% is left. So here we'll be getting 1 by k into ln 100 by 50, which is 2. So ln 2 divided by k. Okay, this is basically obviously the formula for T half, we all know, but we will be considering it as T50. Okay, so case 1 now. Case 1, 99.99% completion. Okay, so we will be calling this as T 99.99. This will be equal to 1 by k into ln 100 divided by amount left after time t. So 99.99% reaction is already done. Okay, so the amount left is 0.01%. In 100, if 100% of the reactant is taken, only 0.01% of the part is left. Okay, so let me just calculate the value over here. So what we'll be getting is we'll be getting here 10,000. So ln 10,000. So let me calculate the value. uh, ln 10,000. So we have 9.2103, yeah, divide by k here as it is. So T 99.99, we just give the ratio, T 99.99 divided by T 50 is equal to 9.2103 by K divided by ln 2 by K. So K cancels out, we will be left with 9.2103 divided by ln 2. So we will just calculate the value over here. So putting the value of ln 2, we know that ln 2 is equal to 0.693. Okay, so we'll be getting this as divide by 0.693. So this will be equal to 13.2877%. This will be the ratio value for value of the ratio. Okay. So the question has asked that we have to show that the first order that the T for 99.99% completion is 10 times, almost 10 times more than the 50% completion. So we can see that it is 13.2877 times more than the T50. Okay. So this was all about this question. If you do this question right, like in the proper way, in this proper manner, you will be getting like full marks for this question. Okay, no marks, no, not even a single mark would be deducted for this. Okay, each and every steps are perfect, and you have to write them in according to this part only. Here will be case 2. I just wrote case 1 in this case, so excuse me for that. Okay. So let us move on to the next question. I don't think we'll be completing the next question totally in this video, so we'll be continuing that in the next video. Okay. So this question says that this is also a part question. So question number 7b. Let us move on to this question, question 7b. So the first part of this question, this question is also divided into two parts. So we'll be just doing the first part of this question in this video, and then we'll be continuing to the second part in the next video. Okay. So the first part of the question says, what is inorganic benzene? Okay, and write down its structural formula. This is a question of basically 5 marks. So you have to just write up to the point answer, just small answer, and you will be getting the full marks for that. Okay, so basically borazole. Okay, borazole, or you may say borazine. Both of them are the same compound. So this one is the old convention. This one is the old convention, and this one is the new convention. You may write any one of them. You will be getting full marks for that. So borazine or borazole is known as the inorganic benzene. Okay, known as inorganic benzene. Okay. So let me just draw the structures for you, and then I'll be explaining. You please note down the thing that I am pointing out. Okay. So we have N, B, N, N, B. So we have H over here. We have H, 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 and H. The lone pair of N is donated here. This lone pair of N is donated here, and this lone pair of N is donated here. Okay. So this structure is known as borazine. Okay, or borazole. So this one is known as inorganic benzene basically because of many factors. Let me write them down one by one. So the first factor is this in like the benzene, this also has two canonical forms. So the first canonical form is already drawn in the screen. Let me draw the another canonical form. N, B, N, H, 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 and then this nitrogen would donate over here, this nitrogen would donate over here, and this nitrogen would donate over here. Okay, so two canonical forms are there in accordance with the benzene, because we know that benzene has these two canonical forms. If we just write the Kekulé structure of benzene, the Dirac structure is different, but that is a different concept. We are not going into structural isomers. Okay, so these are two canonical forms for the benzene, and therefore similarly two canonical forms for borazine is also possible. Okay. Secondly, borazine also acts as an aromatic species, and undergoes all kinds of like almost all kinds of reaction that benzene undergoes. For example, Friedel-Crafts alkylation, Friedel-Crafts reaction, hydrogenation. Let's say other example, that is um, halogenation, um, attack with Grignard reagent. Okay, Grignard reagent, and almost all kind of reaction that an aromatic species goes through, this borazine compound also goes through that. And because of the structural like the similarity between this and benzene, it is also known as the inorganic benzene. Okay, so you have to write these points, these 2 or 3 points in a very compact way, so that you can get those 5 marks all together. Okay, so that is it for this video. I guess I'll be continuing from question number 7b2 from the next video, and then we'll be completing it. Okay, so thank you guys for this video. I'll see you guys in the next one.